All right, hey everybody, Mr. Withers here. In your notes, you can title today's page Squares and Square Roots. Squares and square roots. And this should be a review, hopefully, from your past, but just a quick introduction before we get into this unit where we're going to need to be able to use these. So we want to make sure that we have these down, that we know what we're doing. So the square root symbol looks like this. You have definitely seen this before, and all that this is asking, whatever is inside the square root symbol, this wants to know what number, so we'll say question mark, times itself comes out to equal that number on the inside. So if we're looking for the square root of x, we are asking what number times itself equals x. The thing that's a little bit funky about square roots is they don't only have one answer. They always have two possible answers. So for example, basic example, square root of 4. If I asked for the square root of 4, we could say 2 times 2 is 4. Or we could say negative 2 times negative 2 is 4. So we have a great symbol that we would use for this when we are actually doing a square root in mathematics. We have a symbol like this. It's a plus sign with an underline. And so we would say plus or minus 2. That symbol literally stands for positive or negative. Positive or negative. And it basically just tells us, hey, we know that two possible answers could be our solution here. It would be the positive version of that answer or the negative version of that answer. It's really important that you have this in your answer, or else your answer is only half correct. You've only shown half of what the actual answer is. So, for example, square root of 16 would be plus or minus 4. We know 4 times 4 is 16, and we know negative 4 times negative 4 is 16. So what I'm going to encourage you to do in your notebooks today is we're going to create a list of all the perfect squares from 1 up to 15. And this will just be a great resource for you to have as you work through your assignment today, as you work through square roots in the future. So finding a clean page, somewhere you know you'll be able to find this to just have as a resource. And I'm going to encourage you to do the following. 1 squared, 2 squared, 3 squared, all the way up to 15 squared. So I'll give you a second to kind of write this down. If you need to pause the video to make sure that you have everything, that's totally fine. 8 squared, 9, 10, 11, 12, 13, 14, and 15. So these are what we call perfect squares. It's a number times itself. And this is going to be a great resource for us as we think about square roots. All right, so 1 squared, or 1 times itself, we know that is 1. What that tells us is that the square root of 1 is going to be positive or negative 1. 2 times itself is 4. That tells us the square root of 4 is positive or negative 2. 3 times itself is 9. The square root of 9 is positive or negative 3. So you can see how these perfect squares can work forward and backward, right? A number times itself equals something. The square root of that something goes back to that number times itself. So we're going to continue on here and just keep filling this out. If you know these, you can work ahead. That's totally fine. We know 4 squared is 16. That means the square root of 16 is plus or minus 4. 5 squared is 25. 6 squared is 36. So the square root of 36 is plus or minus 6. 7 squared is 49. Keep on working. 8 squared is 64. Square root of 64 is plus or minus 8. 9 squared is 81. Square root of 81 is plus or minus 9. and so on. We've got 100, 121, 144, 169, 14 times 14 is 196, and 15 times 15 is 225. If you can memorize these perfect squares, they make your life so much easier. 1 through 15 is really a great place to start. If you really wanted to go up even higher, 16 is 256. That's another one that sometimes is handy to have. Anything above 16, I wouldn't say you have a need for. But 1 through 16, perfect squares, just kind of nice to have. And the more practice you get with these, the easier they'll kind of stick in your memory. But just having this list in your notebook would be really helpful. And here's why we want to have this down and have this in the back of our head. Because what happens if we get asked about a square root that's not on this list? So, for example, and if you need to finish this note, go ahead and pause this and finish copying it down because I'm going to move on to a blank page. For example, what if we saw a problem like this? What is the square root of 70? Well, man, that's not on our list. And so now we've got to figure out, how can I do this without a calculator? Well, if you had a calculator and you typed in your square root of 70, okay, you're going to get a big, long decimal. It's an imperfect square, and that decimal is actually going to repeat forever and ever. If you type this into your calculator and just said the square root of 70, what you're going to end up getting is 8.367, something like that, 8.36, and it's going to go on forever and ever and ever. All right? But how could we estimate this or get close if we didn't have a calculator? Well, the good news is we have a whole list of perfect squares. I know what's right before the square root of 70 is the square root of 64. That's 8. I know what's right after the square root of 70, which is the square root of 81. That's 9. So I know 70 is going to have to fall somewhere in between. The way that I look at this now is that number 70 closer to 64 or closer to 81? I know right in the middle, I could say 8.5 because that's halfway between 8 and 9. But I know that 70 is 6 away from 64, but it's 11 away from 81. So 70 is definitely closer to 64. So if I were going to estimate this, I would say around 8.3, which turns out to be exactly what our calculator tells us. But I'm going to choose 8.3 because that's a little bit closer to 8 than it is to 9. Because I know 70 is a little bit closer to 64 than it is to 81. So this is how we would estimate a square root. Let's do another example of this. So let's say that I was given the square root of 15. Okay? I want to think about what's my closest perfect square on each side. So I know that right underneath it would be the square root of 9, which is 3. And I know right above it would be the square root of 16, which is 4. So I'm looking for something in between 3 and 4. I know that's going to be my answer. So let's look at how far away this is. Well, from 9, it's 6 units away. From 16, it's only 1 unit away. So I'm really, really close to the square root of 16, which I know is 4. So my estimation here, I'm going to go ahead and say like 3.9 because this 15 is really close to 16. So I know that my answer should be really close to 4. If you were to type in the square root of 15 in your calculator, the actual answer is 3.87. So if we rounded that, we're really close with this estimate. Just by looking at what square root or perfect square do I have on each side of this, and how close am I to each of those? Let's do one more. Let's say you had the square root of 130. I know the square root of 121 is my closest perfect square on the bottom side. So that's 11, plus or minus. I know the square root of 144 is 12. That's my closest above 130. So let's think about how far away these are. 121 to 130, that is 9 away. 130 to 144 is 14 away. So I'm a little bit closer to 121 than I am to 144. So let's say our estimate, we know it's going to be between 11 and 12, maybe like 11.4, right? Or even 11.3 would probably be okay. All we're really doing is estimating. What I care about is that you know whatever your estimate is needs to be closer to 11 than it is to 12. So it needs to be less than 11.5 because I know that it is closer, 9 units, than 14. It's closer to 11 than it is to 12. If I were to type this into my calculator, square root of 130, I would get 11.40, 175,425, a bunch of decimals after that. But 11.4 is going to be a really, really close estimate. So on your assignment today, if your square root is perfect, something like this, you would just say plus or minus 11. But if you have something like you're going to have on numbers 17 through 30 today, where it's not perfect, something like this, I don't care about your exact answer. I just care that you understand what two numbers is it in between and where is it closer to. So in an example like this, you could say 11.2, you could say 11.3, you could say 11.4. Those would all be correct answers because you showed me that you know it's between 11 and 12 and it's a little bit closer to 11. Okay, if I gave you something like the square root of 8, I know on the top side the square root of 9 is 3. On the bottom side, the square root of 4 is 2. This is 4 away. This is 1 away. So what I care about with your answer is that you know this is 2 point something. It's between 2 and 3. And that you can understand, hey, this is closer to 3 than it is to 2. So I would hope you would say 2.7, 2.8, 2.9. Any of those are fine answers for me, as long as you show that plus or minus sign, so I know that you understand that, and that your answer is bigger than 2.5. Because then I know that you understand this answer needs to be closer to 3 than it is to 2 because of this distance away right here. So on your assignment today, and I'm going to give you the rest of the time to work on this, you're going to be on page 558. This is posted to Canvas as well. And you are doing numbers 11 through 30. And you're going to do they're all just square root problems. They should not take you very long at all. On numbers 17 through 30, that's where you're going to use that estimation. So all that I would care about on those is, are you showing me that it's between the correct numbers and that it's closer to one or the other? 11 through 16 should come out as perfect squares. You should be fine there. Once you get to 17 through 30, you're going to want to use estimation. So your assignment today, 11 through 30 all. This is due tomorrow, but I think I've left you 25 minutes, almost 30 minutes to work on this, as long as you started the video right away, so you should be in good shape. If you have questions, feel free to ask the sub or drop me an email. Otherwise, I will plan to see you tomorrow, and we'll continue with this unit. Have a great day.